So we're talking about central angles and the arcs that are formed by those central angles. You'll remember that a central angle is an angle with a vertex at the center of the circle, and the two sides are good. For example, in this picture, we can say that what is a central angle? ABC. The sum of all these central angles in a circle adds up to how much? In degrees. Almost. 360, good. 180 is halfway around. 360 is a full circle around. And the new knowledge that we're getting right now is pretty intuitive, but if it's 360 around the inside here, wouldn't it also be 360 around the outside? So that means that the measure of this arc will be the same as the measure of the central angle. The measure of an arc formed by the endpoints of a central angle is equal to the measure of that central angle. So for example, if we're looking for the measure of arc AC, remember with only 2 letters, I'm going to take the shortest path. What kind of arc do we call that? Good, a minor arc. So if this is 84 degrees, that minor arc will also be 84 degrees. What does it mean when I see something like arc ADC? Good, the major arc going the other way around. And although this is a very odd looking central angle, theoretically it is a central angle. How big is it? It's 360 all the way around. Very good. 360 minus 84, which is 276. Okay, so we're going to use those concepts to do these problems here. I'm going to do number 1 with us. First thing it asks for is the measure. When I see that measure, I know it's looking for a degree of this arc. So from S to T, I see that I've got a central angle of 122 that exactly matches with that. Therefore, this is 122 degrees. Then it's asking for the measure of RS, this part over here. How can I find that? Almost. Good. We recognize that this part is 180. So to find that, we could say that the measure of RS is equal to 180 minus 122, which is 58. And last one is SRT. So starting from S, working its way around there to T. What do you think? Good. How'd you get 238? Good. Now, I haven't taught you that we've got this additive opportunity here. We did it with segments, right? We talked about the segment addition postulate. If you put 2 segments together, they make a longer one. Or if we did it with angles, if you put 2 angles next to each other as adjacent angles, their measures add up. And the same is true of these central angles and the arc measures. So SRT is the combination of SR and RT. So it'd be 58 plus 180, which is 238. Any questions? All right, let's dig in. Would you guys please talk to your neighbors to solve 2, 3, and 4 now? Go. On Zoom, it looks like there's 3 of you, so let's just treat this as a breakout room. I'm going to put together a breakout room so you guys can talk freely. I would like you to please try to interact, get some understanding. and I'll pull you back when we're done. So the length is equal to a fractional part of the circumference, such that, for example, if I want to find the arc length of this bold part, I would do it in 2 steps. First, I'd find what the circumference is. What's our formula for circumference? Good. Either pi d or 2 pi r. In this case, we're shown that the radius is 6. So I'd say 2 times pi times 6. So my circumference is 12 pi, and I'm going to leave it like that, a nice precise value. Yes, it's sort of like 36, but let's leave it precise. Then I'd say, I want to find the arc length. So it's some fractional part of that circumference. And that fractional part will be, out of 360 degrees, we want 107 degrees worth. So then I just do this in a calculator to get a decimal approximation so that it's rounded to the nearest hundredth. 107 divided by 360 times 12 times pi. I get 11.2050. It says nearest hundredth. So I'm going to call this 11.21 meters. Any questions on that? Looks like 2, 3, and 4 are all very similar problems, so I'll leave those for you to do in a few moments. But let's take a look at these. Let's take a look at number 6. If NR is 8 feet, find the length of NMP. I'm going to color it in just to show myself what I'm looking for here. But step 1 is find the circumference. So 2 pi r, in this case, that'd be 2 pi times 8, which is 16 pi. Then I need to express what the length is going to be. Well, the length is going to be some fractional part of that 16 pi. I know that the denominator is 360. What I'm looking for is the numerator, right? How many degrees does that take? Well, I can see that PM is 180. But how do I find MN to add on to it? Good. Because this 162 is part of NQ, and the remaining part is MN. So if I take 180 minus 162, that tells me that this little part is 18. And so is this one. So I could either say 18 plus 162 plus 18, or say 180 plus 18 is 198. And that's my numerator. That's the number of degrees I've got there.
Can you go up to the first one real quick?
I will, just a moment. Let me make sure everybody got this one.
Okay, thank you.
198 divided by 360 times 16 pi. And so this is going to give us 27.646, which we would round to 27.65. And since these were feet, these would also be feet. Okay, I'd like to send you guys into your collaborative work again to do 2, 3, 4, and 5. Please do that now. Go ahead, I'll take a look at that, and then I'll, just 1 second.
Thank
I'm gonna
you.
open up the rooms for you. Yep. Yes. Hold on, I can't hear you. Say it again, please.
In what order? I got 35.
Okay, so do 198 divided by 360 times 16 times pi.
So this is how
That's it.
Oh, okay, thank you.
Yeah. This one doesn't take anything special. You can just do it in sequence. Yeah. Yeah.